Okay, a tiny metal sphere can be regarded as a point object in space. It carried a charge of positive 0.8 microcoulomb. Find the magnitude of electric field strength at a distance of 20 centimeter around it. Okay, so we have a tiny metal sphere as a point object. Okay, all right, let me draw it out. So we have hold on a second. Okay, let me draw it out. This tiny metal sphere, a point charge, yeah, point charge. Okay, so it is a positive charge, yeah, as you can see, it's a positive charge. So okay, it's a positive charge. This point charge is 0.8 microcoulomb. Okay, so find the magnitude. Just want the magnitude actually of electric field strength. So this is the thing you want. Electric field strength. Electric field strength actually is E. Yeah. Of distance 20 centimeter around it. So be careful with all the units. Yeah, as you can see, this is microcoulomb and this is a centimeter. You need to change it all to SI unit, coulomb and meter. Yeah. So okay, so I want find the electric field strength at, let's say, at 20 centimeter away. So let's say at this here. So want to find electric field strength at this point. Okay, we know. Okay, let's say the direction of electric field strength at this point. It is okay. Let me. Let's say this is a point X. Let's say this is a point X. So electric field strength is away. Yeah, going away from the charge. Yeah, as you learn in the notes. Okay, electric field strength depend on the point charge. If it is a positive point charge, electric field strength is away from the positive charge. But if the point charge is a negative charge, the electric field strength is inward, is towards the negative charge. Okay, so like this case, if this is a positive point charge, so we can say the electric field strength is actually going away. It's actually going away from the positive charge. Okay, this is the electric field strength. So let's say at this point, electric field strength is going to the right. Yeah, electric field strength is going to the right. So that's the electric field. Okay, you can say the direction of electric field is actually away from the positive charge. Yeah, and to calc here I give you the distance. So from the sorry, let me write. So from the positive charge up to the point, it is the distance is 20 centimeter away. 20 centimeter. So change to meter is 0.2 meter. Okay. So okay, now we want to calculate the electric field. Magnitude. So we use the formula kq over r square. Yeah, remember you learn about electrostatic force. Electrostatic force is kqq over r square, but electric field strength is kq over r square. For force, it has two charge. For electric field strength, it only has one charge, which is the point charge. Okay, kq over r square. So okay, let's use that formula. Okay, the magnitude of this vector electric field strength. Use the formula kq over r square. Okay. Okay, so the constant value k is 9 exponent 9. You can find this in the list of constant. Charge is a microcoulomb, so it's 0.8 micro. You need to change to SI unit. Coulomb, so micro is -6. And then the distance r is changed to meter, so 0.2 meter. Then square, don't forget the square. Many students forget about the square below. Okay, so look at here. As long as it is a vector, yeah, vector like force and electric field, below here the r has a square. You see that? It has a square. But for a scalar quantity like potential energy, electric potential energy or electric potential, the R doesn't have a square. It's just R. It's just R. So that's the difference between vector and scalar. Yeah. The vector, the R has a square. The scalar quantity, the R doesn't have a square. So this is a electric field strength. So this is a vector. Vector has a square below. So that's the thing I want you to pay attention. Okay. Okay, let's calculate the value. Let's calculate the value. 9 exponent 9, 0.8 exponent negative 6, divide by this 0.2 square. I got 1.8 exponent 5. 1 exponent 5. What's the unit for this electric field strength? If you look at our formula again, back to our formula, electric field is a force per unit charge, isn't it? Force per unit charge. So force is Newton, charge is Coulomb. So is electric field strength is Newton per Coulomb. See that? Electric field strength is force per unit charge. Force per unit charge. Force is Newton, charge is Coulomb. So electric field strength is Newton per Coulomb. Okay, Newton per Coulomb. That's our unit, Newton per Coulomb. Okay. If this question just asks for magnitude, so you just give magnitude enough. Yeah, no need to give direction. But if let's say the question asks for direction, you can say it is away from the positive charge. Yeah, because it is produced by a positive charge. So it's away from positive charge. Okay. So and then the following questions: determine the magnitude of electric field strength at point X at a distance of 20 cm from a point charge 8 microcoulomb. I think this is the same like that above. The same as above. So again, this is the R. Okay. You have to change the unit, centimeter to meter. This microcoulomb to coulomb, you have to change. And this is still a positive charge, positive point charge. Okay, so the question asks to find electric field strength, also the magnitude only. Find the electric field strength at point X. So let's calculate EX. Let's calculate for a second. Use the formula. Electric field strength at point X is equal to KQ over R squared. I think this question is the same as above, just only the value different. Yeah, this is 0.8, this one is 8. The rest is the same. So K is 9 exponent 9, and then the charge is 8 microcoulomb. So micro is exponent negative 6. Exponent negative. Micro is exponent negative 6 coulomb. Okay, and then divided by the distance from the positive charge, positive point charge. Change to meter, so you get 0.2 meter. Okay, don't forget the square. Don't forget the square. And then what should I get? So let's calculate. Yeah, 9 exponent 9 multiply 8 exponent negative 6 divided by 0.2 square. So I got 1.8 exponent 36. Okay, 1.8 exponent 6 Newton per coulomb. Okay, and the direction you can say it is away. Yeah, because this is still a positive point charge. So the direction is away from positive charge. If this is a negative point charge, then this direction is towards or inward towards the negative point charge. Okay, now is a positive point charge, so it's away from positive charge. If it is a positive charge, the direction of electric field is away from the positive charge. But it is a negative point charge, then the electric field is towards the negative point charge. Okay, that's the difference. Okay, so is the answer correct? Let's check. Let's check the answer. For the first questions, 1.8 exponent 5 Newton per Coulomb, that's correct. And then the rest, 1.8 exponent 6 Newton per Coulomb, also correct. 1.8 exponent 6 Newton per Coulomb. Okay, that's correct. Okay, so that's it for these questions. Okay, see you in the next video.